Great. Okay, so now that you've got this stiffness matrix set up, what I'm going to do is I'm going to just wipe off here, and I'm going to move this matrix towards this side so that we can now talk about what's going on. So now we've computed each element individually, and each of those individually computed elements we've also now assembled into our global stiffness matrix. I'm just going to copy this global stiffness matrix this side, just for convenience sake. So it's 1, 2, 3, 4, 5. Then A, E, B, 0, 0, E, C, F, D, F, B plus G, K, J, 0, 0, 0, 0, Kill, and J. Okay, that should be semi-clear. Okay. See if I do green. No, green is terrible. Oof. Green is terrible. I need to buy new cookies today. Let's go back to red. So this side it should be bright enough. Okay. At least the red cookie is working. Oh, this is nice. Oh, that's nice. This is red. You believe it, but it doesn't show like red on the screen. Okay. So this is what we have. And then essentially we have the unknowns associated with this: Q1, Q2, Q3, Q4, Q5, and then we have the forces that we have applied to the structure. And what we see is beautifully that because we're applying a load F at node 5, when we go through this process of looking at the tractions, we'll see that at node 5 we apply a load of F, and everywhere else there are zeros. Okay, and like we've spoken before, there's actually a reaction here. So the nodes at which we have prescribed displacements, there'll also be an associated unknown reaction force. So I'm going to just add in there plus a reaction which is unknown. Okay, so this is going to be reaction at node 1. That is something that we have. This is not the way the textbook will write it typically, but this is just putting it in there that you understand that there is technically a reaction force that is not known there, that you just keep track of. And when it comes to solving the system, when you do that, everywhere we have a prescribed displacement, that freedom that you've removed, that there's a reaction force there, then when you look at this equation, you immediately say, essentially, I have 1, 2, 3, 4, 5. It looks like 5 unknowns, but I know that Q1 is equal to 0. And then this allows you to say, well, once I've solved for this, I can go and solve for this. But I can't use this equation in the beginning to solve for Q2, 3, 4, and 5. Okay, so this is just to make sure that you can visually see that. So let's go through this process. So first off, what we have is we look at which nodes we have prescribed displacements, and we know that Q1 is equal to 0. So I'm going to replace Q1 by 0, just to make it explicit. But that is a known thing. Okay, so what you need to do is to say, we need to partition our matrix into what is known and what is unknown. That's really what we need to do. Okay. So let's just do this example, and then I'm going to generalize this for the general case. Okay, so let's just start off by saying, in this example, I know that the force balance at Q1 and X1, at this node, node 1, that force balance is essentially a force balance at a prescribed displacement. Okay, so what we're going to do is essentially saying that is associated with a node that is known, and so that force balance we're not going to use in the beginning, so we're going to eliminate it. I'm going to just draw a line through it now, just so that you can see the elimination visually. And what I'm going to say is that what we're left with is that this column Q1, okay, so what we're left with is then these 4 rows. This column Q1 is actually being multiplied by 0. So I can take this on this side, this ED00 multiplied by 1 and shift it towards this side. Okay, and then I'm left with this little 4x4 system. So let's do that. So I can say this is then minus 0 times E, minus 0 times D, minus 0 times 0, minus 0 times 0. Okay, this all just becomes zeros, but that allows me to say now I've eliminated this first column. Okay, and I can do that for every time when I have a prescribed displacement. I can say the node where the force balance is associated with that node, I'm going to eliminate. Okay, and then essentially the column with which I were to multiply that variable that is known, I will shift towards the right hand side. Okay, so that process we can just keep on going at. Okay, that's the beauty of that. Now that we've done with this, we end up with this little smaller system. So I'm going to just write it like this. I'm going to take this away for now. So let's do this. We come back to that when we want to complete the reactions at the end. But this is what we have now. Is our smaller system is now this system here, and now we can go about solving the system for Q2, Q3, Q4, Q5. Okay, because this is now a smaller review system. Okay, and once we've solved for that, we can go back to this node where we had a prescribed displacement, or this equation, force balance at this, and say take this row, multiply it now with the full vector where we add the 0 back in, and that's equal to 0 plus R1, and we can then use that to solve for R1. So we can then solve for all the unknown reactions afterwards. Okay, so that is just to make sure we just quickly see that the way we solve here is exactly the way we've solved before. Okay, let's generalize this in the next